Hey guys, welcome to The Explainer. Today, we're diving into the math that literally teaches machines to hear. Meet MFCC. Its whole job is yanking out phonetic features by straight up mimicking human auditory biology. See, to understand spoken words, computers actually have to mathematically copy exactly how our ears function. First up, slicing audio. We sample at 16 kilohertz, chopping it into overlapping 25 millisecond frames. Then we slap on a Hamming window. This smooth cosine belt suppresses messy frequency leakage between frames. Next, the fast Fourier transform, or FFT, instantly reveals the raw power spectrum of that sound wave. Now, roughly 40 triangular Mil filters act just like our ears, focusing heavily on lower pitch sensitivity. A log transformation then compresses dynamic range, cleverly turning complicated source filter multiplication straight into simple addition. Next up is the DCT. This discrete cosine transform mathematically untangles and separates all these features. Out of all that crazy math, we distill it down, keeping literally just the first 13 coefficients. Why? Well, we want the overall vocal tract shape, completely ditching the distracting, rapid pitch ripples. We then inject the dimension of time itself, just appending delta and delta-delta features to the mix. The final result? A perfect, precise 39-dimensional feature vector generated for every single audio frame. And this whole assembly line operates at blistering speeds, processing about 100 frames every single second. So, what other human sensory experiences could we mathematically strip down to their bare essentials? Something to ponder.